Hello friends, it's my aquarium chiller. I made this one in my home. It has FR11G compressor which is 1/3 HP Danfoss. So its normal current will be 2.2 ampere which is too high. That's why I am trying to connect running capacitor to reduce its current. That's why I made this operation amplifier circuit which I have explained in part 3. And I hope you have seen part 3, part 2, part 1 because all parts are linked with relay, starting capacitor and running capacitor connection. Here I am going to start part 4. I shall explain here how running capacitor will affect the electric bill. Is running capacitor reduce electric bill? Yes or no? Let's discuss on this point. Now my system is running and here this one operation amplifier circuit which I have explained in part 3. This one water flow sensor circuit. This one is 555 timer circuit which I have explained in part 3. This timer on compressor, after that gives signal to this operation amplifier circuit, and after 40-second delay this blue relay on which connect the running capacitor with compressor. Next point came how much running capacitor I can connect. Here are the options: 4.5 microfarad I can connect, 10 microfarad I can connect, 3.5 microfarad I can connect. And this one is the starting capacitor 80 to 110 microfarad. It has no link with this running capacitor. Running capacitor is only this one, this or this. So to finalize which one is the best running capacitor, 4.5 can be used. Mostly people, our friend, I have discussed, many persons said 4 microfarad is okay, but not confirmed. That's why I brought this meter. This is smart socket. I can see here power factor and current. And now compressor current is 1.8 ampere, 1.9 ampere at this meter, and this was showing 2.1 because it will show 0.2 more. That's why 2.1 ampere. Wattage is 284 and power factor is 0.59 or 0.6. Now if I connect the running capacitor, then we will see. Before connecting running capacitor, we have to see this circuit should be on. Now this is on because it has 40-second on delay time. After 40 seconds, this circuit will on this relay, and from this relay I can connect the running capacitor. Now I connect this running capacitor carefully because system is running, it can be short. Here I connected. Current decreased to 1.5, and if I see here power factor 0.67, it means 0.1 increase. That's why current decrease. Okay, now I connect 10 microfarad capacitor very carefully because system is running. Oh, this wire short, no problem. Very carefully I have to connect this wire. Here I have connected this, and now we see current 1.2. Now if I check here, power factor is 0.81 which was before 0.67. It means with 10 microfarad power factor improve. That's why this current decreased to 1.2. Now maximum power factor can be 0.9. I remove the capacitor, open the wire. That's why power factor again decreased to 0.6 and current increased to 2.1. Now I connect both capacitors and then we will see what will be result. Wait. Here connected 10 microfarad. Or same time I connect this 4.5. Both are connected very carefully, and my system is running with 1.17 current, and here if we see power factor 0.91. This is the best result I can achieve with 14.5 microfarad capacitor. By improving the power factor, I reduce the current 1.1 from 1.9 ampere. But this will not give me the benefit to reduce my electric bill. Why? Let's discuss on this. Power have two components, active and reactive. Electric bill came on active power. That's why if I see at this meter, this is 300 watt with 0.93 power factor. If I remember before, when I did not connect this running capacitor, the power factor was 0.59 or 0.6 and my current was 1.9. But this power was near about 290 or 300 watt, same like this. It means this running capacitor is not working. There is no benefit of this running capacitor. Let's talk a little bit on this point. Electric power has two components. One is active, second is reactive. Reactive power needs inductive load like compressor, motor, anything which have winding, this fan. They need reactive power to make electromagnetic field inside winding. If I will not connect this running capacitor, then this compressor or any motor will draw extra current to produce that reactive power. Same was happening here. That's why the total current was 1.9 ampere on this meter and my power factor was 0.59 without running capacitor. And if I see active power on this meter, that is 290 watt. This was before the same 290 or 285 when the current was 1.9. With current 1.2, it's the same because this is active power and my electric bill came on active power, not reactive. It means by improving the power factor, I have no benefit. It looks from this situation. But this is not the correct. Let's discuss what will be the benefit of this improved power factor. With this improved power factor, my compressor or motor remain cool because the electric current which flow inside the compressor is less. So there will be less heat. If compressor is not heated, then the efficiency of the compressor will increase. It will cool more. If it will cool more, then it will trip quick. Then my electric bill will reduce. Second, if it will increase its temperature, I have placed one sensor here, this one. Now temperature is 34.9, 35 degree. If I remove the running capacitor and the current again go to 1.9 ampere, this temperature will increase very fast. Then the gas inside the system R134A, pressure will increase. Then compressor need more active power to force the gas inside condenser and my current will increase from 1.2 to 1.3. This will happen in next month when there will be more ambient temperature and my system will be heated too much. But with this running capacitor, this temperature remain maximum 58 degree centigrade. But if I don't use this running capacitor, then this temperature will go to 68, 10 degree increase. That's why I use this running capacitor to keep the system cool as much as I can. Then my system will work efficiently and trip quick. The result of this, my electric bill will be less. Hope this video will help someone. Still, if I did something wrong, any friend can tell me in comments so that I can make it correct. Thanks for watching. Take care. Bye bye.